Hello students, here we are going to cover the topic theory of vibration. We are going to cover the single degree of freedom system. Single degree of freedom system here with force vibration, 2 degree of freedom system, undamped vibration, how to control the vibration. Now we are going to see first why do we really care about the vibration. Because the vibration is the wasted of energy which is not utilized anywhere. The major cause of premature component failures. Component fails due to the vibration and due to the acceleration and unfluctuated loading. Also, the another cause of the vibration is creating unwanted noise and sounds, which is not at all recommended for to hear to the human being. We are going to see what is the vibration is. Vibration are the fluctuation of mechanical or structure system about an equilibrium position. Suppose there is one mass attached with the spring and it is fluctuating along a neutral axis. Then we say that it's going to vibrate. In vibration, the potential energy due to the height it get displaced from its equilibrium position. This displacement of potential energy will be converted into the kinetic energy. In vibration there is a one term called as natural frequency and how to determine it. So we know that each elastic system with a linear characteristic have n degree of freedom and n degree of natural frequency of acceleration. When we say the natural frequency, the frequency at which any component oscillate by its own without the application of external forces. There are frequencies with which the system vibrate after unbalance. Each natural frequency corresponds to certain form of vibration. There are some vibration which is occurring due to the external applied force, which is called as a force vibration. The system oscillates due to the force applied from externally. If the frequency coincide with the one of the natural frequency of system, there would occur a resonance phenomena. So to avoid the resonance phenomena, we will design the system up to the natural frequency value. The increase in the amplitude of vibration at resonance lead to the large displacement and strain and thus dynamic loading of structure. The resonance phenomena is a harmful phenomena at which any system gets failed during its operation. So we will calculate this natural frequency with the help of some model analysis which allows us to avoid the phenomena of resonance. Let's see the classification of vibration. Vibration are classified as a free vibration, force vibration, damped vibration, undamped vibration, single degree of freedom system, multi-degree of freedom system. So here in figure A, we will see the undamped free vibration. What is meant by undamped free vibration? Supposing there is a mass m which is attached with the spring, which is attached at a fixed position. When we have some static deflection in the spring, the mass got oscillated along its equilibrium position. This deflection is called a static deflection, and this movement with the free length of spring without application of external forces is called free vibration. And why it is called as undamped? Because there is no damping or there is no restriction to the motion of the oscillation of the spring. So the mass get oscillated from its equilibrium position. If we draw the free body sketch of this system, it's having the stiffness value, that is K, which is having the displacement of XO, that is original displacement, with the static displacement value, that is plus delta ST, which is a restoring forces. K into bracket XO plus delta XT is a restoring forces, and the force due to which the mass get displaced is denoted by mg. It is due to the gravitational force. Another type is the damped free vibration. Here we have a system with a spring and mass along with the damper added to it. The damper is denoted by the letter C, and the last system is the force vibration. Here we have a damper, stiff spring and mass, but the forces applied is the external forces. So we are defining this free vibration undamped single degree of freedom systems with some mathematical formulation, which is written as the restoring forces, that is Kx equal to mx double dot. So the mx double dot is opposite to Kx forces. So we are going to arrive at the equation of mx double dot plus Kx equal to 0. 0 means it's a free vibration. It don't have any external forces applied into it. And why it is called a single degree of freedom? We know that the degree of freedom means there are 6 degrees of freedom. 3 for translation, 3 for rotational. If there is a single degree of freedom means we are having the displacement only on one direction, that is either on x direction, either on y direction, either on z direction, and rotational displacement is going to be a zero value over here. So this is the characteristic equation which we arrive by the Newton's second law of motion. We get submission of forces equal to mx double dot, which we can written as a mx double dot. X double dot is the acceleration for the mass equal to mg, that is a force due to gravity, minus stiffness K into x plus delta. X is the original position, delta is a static deflection. So if there is a free vibration, then we can written it as a mx double dot plus kx equal to 0. So kx plus delta is a spring force, and mg equal to mx double dot is a force due to the acceleration of the masses. This is our characteristic equation for force undamped single degree of freedom vibration system. Further, it can be written as x double dot plus k by m into x equal to 0. The above equation is a second order differential equation solution. Must have a two arbitrary constant. X is having the arbitrary constant as a sin omega t plus b cos omega t. By defining the circular frequency omega n by equation omega n square equal to k by m. Therefore